So we're in 2.3 talking about some properties of real numbers. And if looks like my handwriting got neater while I've been at home. I think what happened was I had a messy board left behind with my lesson already prepped for video, and I think Mrs. Pryor wanted to clean my board. So I think she erased my stuff and wrote it back up, and she writes more neatly than I do. So my handwriting has gotten no better, sorry. But this lesson, if we were here in person, the main thing you'd be looking to do tonight is just memorize some of this stuff. We'd be taking some quizzes on this. So this is the third day in a row that we've had some things that need to be memorized. The first day of video, we had an order of operations thing. And someday, when we get to quizzes and tests and things and in-person life again, there will be a quiz on the order of operations coming. I'll prep you once we're back, or give you some warning on this. But if you don't know the order of operations, you should go back and look that over again and try to study that a little bit each day, so you're not coming back with a million things to learn. So the order of operations quiz would come in with what is the order of operations. So maybe pause the video and see mentally if you could do what the order of operations is. All of these videos work a lot better for you to learn if you pause the video once in a while and actually think or write or do or involve yourself in action. If all you're doing is passively sitting on the couch eating chips watching these videos go by, it isn't going to sink in as much as if you engage and write and think and do. So my first question for you, and you can pause after the question and then I'll do the answer. On the videos I don't really do the pause time like I would in class, because that's just sort of stupid, me standing here in an empty room pausing and waiting and watching the clock tick. You can pause me at home and do your own think time, write time. But order of operations quiz would ask, what is the order of operations? And the answer is, first place was parentheses, second place was exponents, third place was multiply, divide, fourth place was add, subtract, and then on ties we work from left to right. And that would actually be 7 points, because on some of those levels I said 2 things. And then it would ask, what good does that order of operations do you? Okay, so what good the order of operations does you would need an answer that has something about order in it, and the phrase one right answer, and form a sentence that has that word and that phrase in it. Something like, tells you the order to do a problem, so you have one right answer. And that would be 8 points out of the 10 on that sort of thing. And I know it makes a larger quiz, I know it makes the chapter test, it's just on there. You're going to have to write that at some point for a grade, so you want to work that into your brain. The second thing we had that we talked about yesterday in the 2.2 video was a lot of rules for exponents. And I'm not going to go through, I don't think, again, all the rules for, you know what, I'll go ahead and go through the rules for exponents. And you could give yourself a little self-check on this at home. I think this was in yesterday's video as well. But the questions for this are, and again, engage if you're at home. I'll ask a question, pause, think, and then see if you got it right when I start talking again. What is 1 to any power? And that answer is 1. What is 0 to any power? That answer is 0. What is anything to the first power? That is itself. What is anything to the 0 power? That is 1. What's a negative number if it goes to an even power? That is positive. What's a negative number going to an odd power? That is negative. If there's a negative sign in front of a number to a power, but not in parentheses, what does it do? If there's a negative sign in front of a number that's to a power, but not in parentheses, what does it do? It's going to change the sign at the end of the call. What the negative exponents do? They flip things. What's another name for the second power? Squared. What's another name for the third power? It's cubed. For a problem like this, what are those numbers called? The 5 has one name, the base. The 3 has 2 names. It's an exponent or a power. And that's the vocab. So that should be in there. If that's not in there, rewind, do it again. or set it aside, come back to this video tomorrow, find that time slot, do it again. You could use that little video thing as a self-test once, twice, 1,000 times if you want to. But you want to work those into your brain. Don't wait until it's like the day you're back in school and I'm like, okay, here's the days we're taking the quizzes, and 2 weeks from now you're like, I guess maybe I'll study those now. It's going to go in your brain a lot better if you work it in a little bit at a time. Today's grouping, we have properties of real numbers. So there's several properties. You're familiar with some of these from your past. You just might not have ever heard these names before, depending on what maths you've been and what schools and what grade you're in and those kind of things. 7th grade, we never talked about any of this stuff. This is all new. I think the pre-algebra book may have, I don't know. Well, it doesn't matter. So here they are. It's part of algebra life, no matter where you take an algebra course. You're going to hear about a thing called the commutative property of addition. The commutative property of addition is just a very fancy bunch of words that mean you can add in any order. And I think you've known that for a long time. 2 plus 3, that's the same as 3 plus 2. If you change the order of adding, it doesn't change anything about the adding problem. So the commutative property of addition, as we take these quizzes, historically speaking, there's usually a day where I'll do the title and I ask you to do an algebra sentence like A plus B equals B plus A. There's usually a day where I write the A plus B equals B plus A sentence and you write commutative property of addition. A little bit of English help maybe to help you remember this one. Some of you might have heard the word commute. People commute to work. They travel to work. They're called commuters. Commuting means to travel. All we're doing here is we're making these numbers travel, basically. We're taking A and B and we're just switching them. When we do these properties, these rules, these laws, these need to be variables. These can't just be numbers. I can't write that 2 plus 3 equals 3 plus 2. That would be the commutative property of 2 and 3. Okay? And that's not what we want to say. It's not only true for 2 and 3. These properties are true for any numbers in the universe. So if you want to do A and B, then you do B and A. If you wanted to do X and Y, then you do Y and X. If you want to use your initials, then you switch the order. Okay? But any 2 letters will work. Any 2 variables are fine, but we're switching the order of them. So follow-up question, and you can pause and think this through. There's a second commutative property. These are ditto marks. That just means I don't feel like writing commutative property again. Just instant replay, commutative property. It's not only adding that can do the order switch. There's another thing that can do the order switch. Who else can do an order switch anytime you want to do it? And that answer is multiplication. There is a commutative property of multiplication that you can multiply in any order. So do any letters that you want to do. To multiply with variables, the simplest thing to do is put them side by side. I'd rather you not use this symbol for multiplication anymore because it looks like an X, so don't do that. You could do the dot if you want to, or parentheses or other things, but why bother? Commutative property of multiplication, to show that law, pick any 2 variables and then switch them. Second club, there's 2 associative properties. There's an associative property of addition. Let's go a little bit of English explanation to maybe help remember this one. Your associates are people that you're in your group, people that you're with, people you're around all the time, people you associate with is a verb out of that. The associative property has to do with grouping multiple numbers. If I want to do the associative property of addition, I'm going to need at least 3 letters. I'm not going to change their order, but I'm going to group them. By grouping in math, we're going to always talking about parentheses. Okay, so the associative property of addition tells you if you have a lot of numbers to add, you could do the first 2 and then worry about the third, or you could do the last 2 and worry about the first. That's the associative property of addition. You can group these any way you want to group them. It doesn't really matter. Don't change the order, but change the groupings. If you're changing the order, that's commutative. If you're changing the groupings, that's associative. Then follow-up question, and you can pause after I ask the question and think it through. There's another operation that has an associative property. it's not just addition that you can change the groupings. There's another one that we can change the groupings on. Pause me up. And when you come on back, maybe you thought again that it's multiplication. Multiplication also can do an associative property. Pick any three letters, L, M, N. Don't change the order. L, M, N. Just change some groupings. We could group the first two together one way, group the last two together another way. Those are going to get you the same answer regardless of how you group these. The distributive property is something you've never encountered until today. You sort of have had the commutative property in your life. You know you can switch the order of adding. You've had the associative property before. You know adding, multiplying. If you've got a big stack of numbers, you can stack them however you want. Okay, that's what those have been. Distributive property you've never seen until now. So this is also by far the superstar property of this group. We will distribute this year hundreds of times. I won't say 1,000, but it's possible. Okay? Hundreds and hundreds of times we will distribute over the course of the year. So distributing looks like some sort of variable alone outside of parentheses. Inside we could either add or subtract. I'll add just for now, but subtracting is just as fine. And then there's two other variables, let's say B and C. So what this is going to do, this A is going to do like a double multiply. Okay? The A that's it's outside of these parentheses that wants to distribute in, this A is going to multiply everything in here. So we get the A multiplying the B. We won't mess with the sign. If I had written a minus before, I'd write a minus now. And then the A also wants to multiply the C. This A wants to like jump in and multiply everything that's inside. That's distributing. That's going to be a huge thing in Algebra 1 this year that we'll do a ton of. In a minute I'll take a walk to the left and do some distributing problems, but not quite yet. The last group, there's a group of three things called the reflexive, symmetric, and transitive properties. The reflexive property is not very complicated. It just tells you that anything is equal to itself. It's not very fancy, it's just the way that goes. I don't think that's shocking to anybody that every number in the world is equal to itself. For some reason people gave that a name. That's the least useful by far of these properties we have on the board. Symmetric has to do with comparing two numbers, and it's an if-then sentence. And I think you're aware of the truth of the symmetric property. It tells you if you have two equal things, then those things are still equal if you switch them. If A is equal to B, then B is equal to A. Some of you guys have used the symmetric property probably in your past. You've done some equation solving, like x plus 3 equals 10. Sometimes the problem is written like 10 equals x plus 3. And some people don't like that. Some people don't like it when the variable is over on the right. So sometimes some students that I've had before, if a problem's written like this, they flop it. Okay? When they do that, they're making use of the symmetric property. If you don't like the way something looks, and you just want to flop who's on what side, that's fine. Again, it doesn't matter what letters we pick. I'm just randomly picking letters. It's just we need consistency. The letters on the left and the letters on the right within each thing need to be the same within each line. But there's nothing magic about A, B, and C. The transitive property is another if-then sort of sentence, and it's for comparing three things. So here's a memory trick for you. We look at reflexive, symmetric, and transitive. R, S, and T are in alphabetical order in the alphabet, boom, 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 right in a row. R, S, T. When we go to choose how many letters to use, we're going to use 1, 2, and 3. So maybe R, S, T, 1, 2, 3 is helpful to your life. But reflexive, one letter, A equaled A. Symmetric, two letters, we had A and B. We just swapped them. Transitive is if A equals B and B equals C, then A equals C. Transitive property would be like if I said to you, if people were in the room, I'd pick on the people that I have in here probably. I'd say like, hey, if Jacob had the same grade as Aiden, and Aiden had the same grade as Keith, what could you say about Jacob's grade compared to Keith's? Well, they'd have to be the same. With Aiden in the middle, matching that all up, that's all equal. Transitive doesn't just have to use only 3 things. I mean, you could do as many as you want. I could say if Jacob had the same grade as Aiden, and Aiden's grade is the same as Keith's, and Keith's is the same as Caleb's, and Caleb's is the same as Killian's, then what can we do? Well, we could say Killian has the same grade as Jacob. Like all those people sort of link that all together. People try to use the transitive property sometimes in sports, and that doesn't usually work out very well. Like if the Steelers beat the Browns and the Browns beat the Bengals, oh, well, the Steelers will surely beat the Bengals. That doesn't really work out. There is no transitive property in sports, although you'll see a lot of people trying to make those comparisons. It doesn't quite work in sports the way it works in math. But transitive property, you're trying to compare multiple things and work your way through a chain. That's what the transitive property is about. So try to learn these a little bit at a time. Someday this makes the test as well. If we were going to quiz and build up a day at a time, there would have been a day that I would do the titles and you would do the algebra the way we just did it. So if you want to practice that at home, you could do that any day. Grab a scrap of paper, write down the titles, see if you can do those next to them. If you can't, do it again and again and again until you master it. Another way we can do that is write down a sentence like this, and then see if you can do the title for it from looking at the sentence. Grab a blank piece of paper, write that down, try it again and again and again until you dominate it. Ultimately, where this heads on the test is me just saying, hey, tell me about the property. And you're going to need to go name and the algebra sentence for it. If you want to go straight to that already, you can do that. Just grab a completely empty thing and just see if you can write down 8 properties and the 8 sentences that go with them. So the homework we'll do, we have some more examples to do because distributing, I said we take a step left and that would be our superstar. The homework's going to be on 61. There's a 1 to 6 that has you just doing math using these properties. And then a lot of the homework, then there's a middle group where they're going to give you stuff like this, and you'll have to spot which property it is. And then the last group, you're going to have to do some distributing. So here I go with a step left to distribute.
Oops, I fell on the chair. My bad.
Small tripod stuck in the row. Shoot. Are we still live?
We're still live.
Okay. So they got a little action-packed
yeah, they got
motion sickness moment there.
Yeah.
Okay, that's fine. The best way to probably do this section in video form at home is listen to me do one, pause it, do the other one. Listen to one, do one, listen to one, do one. Because I have these problems coming in pairs. So it's kind of designed to, you have no idea probably how to start these right now. So I'd listen to one, pause it, and do one yourself. And I'll just talk my way through. But they're a little bit like Noah's Ark here, 2 by 2. So what we're doing for all of these, this is all called distributing. Distributing is we have something that's in front of parentheses. And then in parentheses, there's either adding or subtracting inside, and it doesn't really matter. Okay, sometimes what you're trying to distribute is just a number. Sometimes what you're trying to distribute is just a sign. Sometimes you've got both. So if you're distributing a number, all you're going to do is take this number, and it's going to multiply everything inside. So 2 times 3 makes a 6. Don't mess with the x, just copy it. Don't mess with the plus, just copy it. And 2 times 7 is 14. That's all distributing is. It's like a double multiply. The number in front of the parentheses wants to multiply everything inside. So now pause me, try one yourself. If 5 is going to multiply both things, that's 30x minus 45. If 5 multiplies both numbers. If we're distributing a sign, all this is going to do is switch all of the signs inside. So this wants to switch this sign, this wants to switch this sign. We encountered a thing like this on exponent day, and I mentioned that on the exponent quiz. A negative out front just wants to switch the signs of things later on. So this is going to switch both signs. So the 2x is going to be positive, and I don't need to write a plus because it's the beginning of the line. Here in the middle, I need a plus, and then the 3. We're not changing the numbers, we're just changing the signs. So pause me, try one. Okay. If we change the signs on this and this, it's going to be a regular 3x instead of a negative, and a -4 instead of it had been a +4. Now this we're going to do both. Okay, the 2 is going to multiply the numbers at the same time that the negativity of it is going to change both of the signs. So 2 times 3 is 6. Don't change the x. 2 times 6 is 12. Since this was a minus, we change it to plus. And since this was positive, we'll change that to a negative. So then pause me, try one. For this, 5 times 2 is 10, it's still an x. 5 times 4 is 20. This was a negative, so now it's positive. I don't need to write a plus sign in front at the beginning, but I need to change this plus to a minus. For this, if there's parentheses with nothing in the front of them, or if there's parentheses with a plus only in front of it, there's no number, there's no negative sign the way we just were over there, that's not distributing, that's just a distraction. Okay, those are useless. So a question like this, parentheses with nothing in the front, just erase them. Parentheses with just a plus in front, just erase them. Then you could pause me and go after the problem, just worried about the other set, and then you could come back after you do both of those probably. For this one, I'm going to go 5x plus 6, just copied, plus a 6y plus an 8z. The only change I had to make is that the 2 had to multiply the 3 and the 4 to make these numbers. For this one, I'm going to go 18x plus 6 plus 5y plus 3z. Again, the only change here is the 3 multiplying to make 2 new numbers there. These two, there's nothing new. It's just a matter of doing stuff with fractions. So people that are fraction strong, go ahead, pause the video, just do it. People that are fraction medium or weak, maybe you want to try it, maybe you just want to listen to me do it, I don't know. But fractions always take it down usually a level of accuracy. Fractions usually cause people a little bit of trouble. Shortcut way to think of this one, if you're doing half of things, just divide by 2. Anytime there's a 1 on top of a fraction, and we're trying to do a multiplication, the shortest way to do this is this divide by the bottom. So to do half of these numbers, just take these numbers, divide by 2. So the x would have a 1, the 6 would become a 3, the minus we're just copying as we distribute. A half times a 2 is a 1, a half times a 6 is a 3. If you didn't like that, that shortcut fooled you for some reason. Take these fractions on a step to the side. A half is trying to multiply a 2. That's what this multiplication is like. That's over a 1. Cancel, cancel. That's a way you could get the 1. If you're trying to do half of 6, do half times 6 over 1 again. Cancel, cancel. 2 into 6 goes 3. That's another way you can get 3. 3/4 needs to multiply 12 here, 3/4 needs to multiply 6 there. But as we do this, the x is going nowhere but getting copied. The plus is going nowhere but getting copied. To do 3/4 of 12, if you can't do that, if you can do it in your mind, great. If you can't, just take 3/4 and 12 on a little walk. 3/4 multiplying 12. 12's like it's over 1. A little bit of canceling. 4 goes into 12 3 times. The 3 multiplies the 3 and gets us a 9. Likewise, take 3/4 and 6 on a walk. 3/4, 6, multiplying, put it over 1. Mini cancel here. 2 goes into both of these numbers. 2 into 4 goes 2. 2 into 6 goes 3. Multiplying across, we get a 9 over 2. And that's fine. If you don't like canceling, you could have gone straight across. 3 times 6 is 18. 4 times 1 is 4. But you'd still have had to divide these each by 2's later to make that happen. And that's like all having to do with distributing. Distributing is easily the star of the show today for what we need to master for our year. One of the great truths of math stuff is anything you can do forward, you can do backward. So in a few of these homework problems, what they're going to have you do is undistribute. It's not a real word, but just to describe in a made-up word what we're doing. Some of the homework questions just want you to turn this process around. They're basically saying, hey, we already distributed. We came up with the answer. We want you to figure out a way to reverse back. So what you're trying to do is come up with an answer that has parentheses. Some number out here multiplied to create these. So essentially what we're doing, if we're going in backward, reverse, opposite order, we're dividing now. Okay, so what we've been doing is we've been multiplying to produce answers. They're giving us an answer. They want us to produce a problem from a certain point of view. You're going to have to divide. So you're thinking about greatest common factors. What can go into these numbers? Okay, with 6 and 14, 2 can go into both of those. So we're going to put a 2 out there. And then we're going to divide these both by 2's because we're working backwards. What we've been doing up till now, whoever's out here multiplied in. Now we have to divide something out. So if we divide these both by 2, there'd be a 3 and a 7. And just don't mess with the x or the plus. Pause and see if you can tackle these next 3. For this one, my first thought would be, what can go into both of those numbers? What can go into both of these numbers is 3. So put 3 there. Leave the x alone, leave the minus alone. And we want to divide both of these by 3's, which would make another 3, and then 12 divided 3 is 4. Same thing here. You think about who can go into both of those numbers. 7 can. So 7 comes out. Make your parentheses. Don't mess with the signs or the variables really. And then you want to divide these both by the 7 we decided went into them, which leaves a 2 and a 3. The last one's a little weird because if you think what goes into 3 and 7, really nothing other than 1. And if you try to divide by 1, nothing would happen. So that's sort of silly. This has a different approach. It's not the numbers that have anything in common. It's the variable this time that's in common. These both have the same variable. So pull out the variable this time and leave the other stuff in there. Still a plus in there. If we pull the x off of both of these things, you'd be left with 3's and 7's. If you wanted to get fancy, there is another correct answer to this. I don't know why you'd want to do this, because it's a more complicated way to do it, but it's still true. A positive 2 is not the only number you could pull off here. If you wanted to go a little bit fancy, you could pull off a negative 2. You don't have to. It's a what if. Pulling off a negative is the same as putting in a negative. It would just switch all the signs. Instead of positives, we make these both negatives. You don't have to do that. It's just an option. Here I could have pulled off a negative, which would have made this negative and this positive. If that confused you, act like I didn't say anything in the last 30 seconds. Homework we're doing from this, again, we're on page 61. We're working 1 to 6 and then 15 to 26. And another great idea is just rehearse some quiz fact info.